In this example, we have this airplane, which is attached to this 20-meter long piece of rope. And we pull this airplane up from the ground until the angle between the rope and the vertical axis is 60 degrees. Once it's at 60 degrees, we release the plane from rest, and the plane comes and hits the ground. And when the plane hits the ground, the angle that the rope and the vertical axis makes is 15 degrees. And what we're asked to figure out is the velocity of the plane right before it crashes. So if we draw a quick free body diagram, we notice that the only two forces that are acting on this plane is this tension force right here and this weight. And the weight acts straight down. Our tension force does no work on the system because it's always perpendicular to the path of motion, because this plane is moving in this circular path, and the tension of the rope is always pointing back up towards this point right here. So it does no work on the system. So all the forces that do work on our system are conservative, and because that's only the weight. So because of that, we can use the conservation of energy. And the conservation of energy says the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy plus the final potential energy. And for our particular system, we can simplify this a little bit. We know that at this point A right here, and let's call this point B, so this is our kinetic and potential energy at point A. This is our kinetic and potential energy at point B. At this point, we start from rest, so our initial kinetic energy is 0. And why is it 0? Well, kinetic energy is equal to 1/2 times our mass times velocity squared. We start from rest, so our velocity is 0, and therefore our kinetic energy is 0. Now, our potential energy is going to depend on where we put our datum point. We can put our datum point up here. I'm going to choose to put mine on the ground. And where we choose our datum point, it's very important to remember our datum point is a line that has 0 potential energy. So at this point B, our plane is right on our datum point. So we're going to have no potential energy at point B. So this is going to turn to 0. And it's also important to remember that anything that happens above our datum line is going to have some positive potential energy, and anything that happens below our line is going to have negative potential energy. For this problem, everything that happens above our datum line, so we're only dealing with positive potential energy when we dimension our datum line on the ground. However, if we had dimensioned our datum line up here, then everything would have happened below our datum line. And since it would have happened below our datum line, we would have had to have negative potential energy. But since I dimensioned it on the ground, everything is positive potential energy. Okay, so we don't have any spring force. The only potential energy we have is gravitational. So I just need to figure out the height of this plane right here. How high is it off the ground? Well, I know I can figure this out if I call this distance right here L2, and I want to figure out this distance right here. I can call this L1, and I can figure out this distance right here, which I'm going to call L3. I know that L2 plus L3 is going to be equal to L1, right? This entire distance right here is going to be equal to the distance to the plane plus the distance from the plane to this top line. So how can I figure out some numerical values for this? Well, when the plane is on the ground, we know that the length of this rope is 20 meters. So this length L1 is going to be equal to 20 times the cosine of 15. And 20 times the cosine of 15 is equal to 19.3. And then I can figure out what L3 is. So from the top, L3 is going to be equal to 20 times the cosine of 60. And if this is our right angle right here, it's going to be 20 times the cosine of 60. And we don't know what L2 is, but 20 times the cosine of 60 is just 10. So we have L2, which is the length we're looking for, how high the plane is off the ground, plus 10 is equal to 19.3. So we know that L2 is going to be equal to 9.3 meters. So this is how high the plane starts when it's off the ground. So potential energy is our mass. Potential gravitational energy is equal to a mass times gravity times a height. So our mass is 8,000. Gravity is going to be 9.81. And our height is going to be 9.3 meters. Now this is going to be equal to our final kinetic energy, which is going to be 1/2 times our mass times some velocity squared. This is the velocity that we are looking for, so we're going to leave it as a v. Now if we solve for velocity, we get the velocity at this point B, so this velocity is equal to 13.5 meters per second. So this is how fast the plane is going when it crashes.